Hello, my name is Taha Shaffa, and I just finished the analog sensors lab, and I'm going to show you what happens when I turn my potentiometer, and I'm going to show you the robotic manipulator moving parallel to the x0 direction and parallel to the y0 direction. We're going to start with the potentiometer. It's a simpler program. This is the program right here. It basically just takes the potentiometer reading, and this little calculation right here is what converts it from the bits being 4,048 bits in total to degrees. So I'll show you the program is already being run, as you can see right there, and I'll show you the potentiometer. It is right here, and it will move it'll be easier if you see it like this. It moves, as I turn it here, you see the number increasing, and it increases to a maximum of 360 degrees. I'll turn it back. And so you see a full rotation is measured through the LCD screen. So that was the first part of the lab. The second part of the lab requires me to load up this new program, so I'll go into Jacobian, set it as the active project. I will show you what the code looks like. So this code is a bit more complex. We have the subroutines for angle, theta 1 and theta 2. And through some calculations, through calculating the J11, J12, 21, and 22, and their inverse, I am able to make it so that by manipulating these x dot and y dot values, I can actually make the robotic manipulator move parallel to the x0 position and y0 position. This is because when you set the y dot to 0 or the x dot equal to 0, then it does not move in that direction anymore. I will show you this firsthand by loading up this project. So right now, I have it so that the robotic manipulator will move parallel to the x dot, and I didn't change the angles. I still had the angle starting at with angle 1 being at 0 and angle 2 being at 90, because I thought this was a nice way of showing how this actually works. So I'm going to run the program. Here's my robotic manipulator. It started at the 0, 90 position with the two motors, and then it moved in the x0 position, parallel to the x0 position, excuse me. I'm going to run the project again, so I'm going to hit this reset button. Now watch closely as the marker moves along the x-axis. You see how that is parallel with the x0 axis? Now it keeps moving until it cannot move in that direction anymore. I'm going to do the same thing, but this time with the y0 axis. I have the x dot value at 1 because I feel like the slower it moves, the easier it is to see. I'm going to change the y value to 1 for the same sort of reason. So I will load this program. We'll take a look at my manipulator. So now we'll see as it travels parallel to the y0 axis, just like the other one. So, one more time, in case you want to inspect my code, this is my code from top to bottom. I included the math library. This is the main function. These are all my variables. And this is how I calculate all of my matrices, my angles, and the velocity at which to increment these thetas, controlling how fast the robotic manipulator moves in whatever direction I want it to.